Okay, so carrying on with integration, we did algebraic integration and exponential integration. And today we'll be doing trigonometric integration. First of all, let's recall differentiation. What was the derivative of sin x? Cos x.
The cos x.
Well done. And the derivative of cos x was?
Negative sin x.
Yes. And what about the derivative of tan x? That was sec square x.
So 6 square x.
Is this right?
Yes, sir.
First, I'll discuss the first few ones and then I'll go on to integration. Okay, now how will we integrate it? We know the integration is the reverse of differentiation. If I ask you to integrate cos now, please answer very smartly. What will be the integral of cos?
Sir, sin x plus c.
Well done, it will be sin x plus c. And what if I ask you to find the integral of sin x now? What will be the integral of sin x?
Sir, voice is lagging.
I'm asking what will be the integral of sin x?
Sir, negative cos x.
Well done. The integral of sin x is negative cos x plus c. I'm not going on tan x right now. I'll explain it to you later on, but just writing it down and giving you a bit of hint that if I were to integrate sec square x dx, what will I get? Tan x
Tan x.
plus c, right? Just keep this in mind. We'll be doing it later on. Just pin it to a point where you understand it. Okay, similarly, if you had to differentiate sine and there was a function as an angle, mostly we had a linear function. What did we get?
Sir, cos fx.
Angle does not change, yes. And it multiplied by the
A derivative.
of the angle, right? Is that right?
Yes, sir.
Now again, using a very easy example, if I were to differentiate sine of ax plus b with respect to x, what did I get? Cos of ax plus b, and it multiplied by the derivative of the angle, which was a, and we understood it through the chain rule, remember?
Yes.
Now, if again I have cos and another function of x, and if I add an angle and I need to integrate it, yes, what should I do?
Sir, voice is lagging a lot.
Just wait on.
Sir,
Now, what will be the integral of cos if I have a function? So if I were to break down in the
this
process, I'll just sin का different derivative cos होता है और फिर angle के derivative से multiply हो जाता है. So keeping that thing in mind, what will you say? क्या होगा cos का integral?
sir, sin x. Sir,
Sin
sin function x divided by
angle
the
does not change. And
integral
derivative of the function
derivative.
plus c. Is that right?
Yes, sir.
Again, using a very easy example to understand it, if I tell you cos of ax plus b dx, what will that be? Sine of ax plus b and divide by a plus c. Is that right?
Yes, sir.
Now again, if I ask you what will be the integral of sine of, if I have a function as an angle, negative cos, and it will be divided by the derivative of the function plus c. Is that right?
Yes, sir.
So these are the basic integrations of sine and cosine. Just make one thing very clear, the angle does not change. One thing that I must express and explain it to you right now, जिस तरह sec का sec square भी होगा तब भी ऐसे होगा. If there is a power on any trigonometric function, for example like this sec square, trigonometry में जब भी power आएगी, you cannot integrate it the conventional way. What is the conventional way? अगर किसी function पे power होती है, algebra में जो था आपके पास, you used
Plus
to take
1
the power,
divided by the power.
but did you do that over here? Did you do that over here?
No, sir.
So trigonometry में जब भी power आ जाएगी, हाँ simple trigonometric functions है, if you have sine, cosine, कोई भी simple trigonometric function है, sine या cos, तो वो तो direct हो जाएंगे. But what if I have a power? Then there are two ways to integrate it. और वो दोनों में से either way is expressed in the first part. You either need to use reverse differentiation like we did in this one. Okay, we already know that sec square is a derivative of tan x. उसको रिवर्स करके हमने कहा इसका इंटीग्रल tan होगा. और फर्स्ट पार्ट में वो कोई आइडेंटिटी हमसे प्रूव कराता है, फिर हम उस आइडेंटिटी को यूज करते हैं एंड देन वी इंटीग्रेट द एंटायर थिंग. इज दिस क्लियर? क्लियर है बच्चे?
Yes, sir. It's clear.
So be very clear about it. You'll either have to use reverse differentiation or an identity which will obviously be proven in the first part. I'm just telling you with respect to the past papers what can be done. Okay, now this one, how will we integrate this? 5. What is the integral of
Oh,
what is the integral
so
of sine?
so
Take your time.
negative cos.
Negative cos. So minus 5 cos, angle does not change.
Upon 3
No,
plus
negative 3.
3, sorry.
Yes.
Plus c.
So that will be 5. I can separately write 5 over 3 as well, or I can put 3 in as an entire denominator. That does not matter. And this is the answer that I am left. Is this right?
Yes, sir.
Okay, now attempt the remaining two. So 2 and the integral of cos is sine of 2x minus 7 divided by the derivative of the angle 2 and then plus c. So simplifying it, sine of 2x minus 7 plus c. Okay, this one 4 sine, sorry, 4, it will be negative 4 cos 1 minus 5x divided by the derivative of the angle which is minus 5 and then plus c. So 4 cos, you can write it as 4 upon 5 cos 1 minus 5x plus. Is this clear?
Yes, sir.
Okay, now a few more questions from question 2. They look in 2 ka part C and D. So we know when things are adding and or subtracting, we integrate them individually. Don't be confused about this pi. Pi is just a constant. You had 3 being multiplied here as a constant, 5 and 2 in the previous parts as well. So pi is just a constant. Do not be worried about that. So the integral of cos is sine 2x and then divided by the derivative of that minus pi. Sine ka it is negative cos of the angle is 5x upon 2 and then divided by the derivative of the angle which is 5 upon 2 plus c. So I'll get 3 sine 2x upon 2. This will become plus pi cos of 5x upon 2. And this divide can be used as a multiply 2 over 5. Remember, this is not being multiplied by the angle, but by this entire value. I'll put a bracket around it to avoid confusion. So 3 sine 2x upon 2 plus 2 pi upon 5 cos of 5x upon 2 plus c. Plus c. Is that right, beta?
Yes, sir.
Okay, well done. And what about the next one? First, we need to make sure it is integrable. So we'll bring the x square in the numerator minus cos of 3x upon 2. Okay, now we can integrate it x to the power -1 divided by -1. Algebra will be integrated as we have already studied. The integral of cos is sine of 3x upon 2, and then divide the entire thing by 3 over 2, which is the derivative of that. You can just multiply it by 2 over 3 as well, minus 1 over x, minus then 2. Okay, I'll just write it as this. 2 sine of 3x upon 2 upon 3 plus. You could have also written the entire thing as 2 over 3. दोनों में कोई फर्क नहीं था, so I'm just explaining it to you again. Rewriting it in just a different manner. Both are absolutely right. You can use any one, but be very clear about the operations that you are conducting. Is this clear?
Yes, sir.
Okay, now let's do a practical example. Another important detail that I want to let you know is once you are integrating any trigonometric functions are involved, please be sure that you're using radians in your calculator. It's again a very common error. Students do not tend to use radians and they end up getting wrong answer. Now, how will we integrate this? Give it a try. So exponential integration powers remain as it is divided by the derivative of the power. Sine ka derivative is negative cos and divide by the derivative of the plus this entire thing calculated in a better way plus 5 over 2 cos 2x plus c. And second one first we'll have to simplify over here. To x to the power -half and plus sine of x upon 2 plus c. Sorry, we must still need to integrate it. Okay, one thing you must be careful for is you integrate the entire thing in one step. Or if you want to integrate separately, you put integrals on each one of them individually.
Yes, sir.
2x to the power half and then divided
One.
by half plus the integral of sine is negative cos of x upon 2 and then divided by the derivative of the angle, which is half plus c. So just simplifying it, 4x to the power half minus 2 cos x upon 2 plus c. Or you can also write it as is that clear?
Yes, sir. It's clear.
Let's attempt another question on how to get the equation of a curve from its derivative. We know if we integrate this, we'll get y. So if integrating cos, I get sine x. Integrating negative sine, I'll just get cos x plus c. Now how to get the value of y? So you
So
have
put
to
in the value of
yes, make
pi
sure
upon 2 and 3.
in radians. In place of y, we'll put 3. In place of the angle, we'll put pi over 2 and pi over 2. So 3 sine 90 is 1, cos 90 or cos pi by 2 is 0 plus c. So the value of c is 2, y equals to sine x plus cos x plus 2. Is this clear?
Yes, sir. It's clear.
Okay. I'll give this one a try. Because it creates issues further on. We try to keep C as exact. Okay, what do we get? Y, we get Y once we integrate this entire thing. 1 minus 4 cos 2x. Okay, so the integral of one is x
X
minus
minus 2 sine
4
2x
sine 2x upon 2 plus c.
plus c.
So y
And
is
then 2
x
plus
minus 2 sine 2x plus c. Now, in order to figure out c, we plug in the value of pi over 4 and 1. So in place of y, 1, in place of x, pi over 4. And do not try to put the entire value at once in the calculator. Do the trig bit differently and the non-trig part separately. Now sine pi by 2 is 1, so you'll get this as -2, right? So -2 comes over here, 3 minus pi by 4 is the value of c. This is the exact value of c. Are you getting anything differently? I'm not using a calculator, but I believe it gets something like this. Plus 3 minus pi by 4. Is this clear?
Yes, sir.
So try to keep the value of c as exact so that you don't mess up the equation of the curve if you were to use it in the further parts of the question. Is this clear? Okay, now let's do this one. The dy by dx once you integrate the double derivative, which is 45 cos 3x plus 2 sin x with respect to x. So the dy by dx will be 45 sin 3x divided by 3 minus 2 cos x. So the question has told us that dy by dx is -2. Over 45 over 3 can be written as 15 minus 2 cos of 0 plus c. So minus 2 sine of 0 is 0, cos of 0 is 1. So the value of c is 0. So dy by dx is 15 sine 3x minus 2 cos x. Now I get y once I
Sir, also divided by 3 sine 3x.
know 45 upon
Yes,
3
sir.
is 15, right?
Yes, sir. Oh, you didn't differentiate, integrate.
Yes, we have just got the double derivative. And I integrated it once to get dy by dx. Now if I integrate it again, I'll get y. So this will be
So 5
minus
sine x,
15 cos
5
3x over 3 minus 2 sin x plus c. So y will be -5 cos 3x minus 2 sin x plus c. How do you figure out the value of c? Y की जगह -1
pi and minus 1.
and then 3 pi minus 2 sin pi plus c. -1 is cos of 3 pi is 1 pi 2 pi -1 to plus 5 हो जाएगा. And sin pi is 0, so this will become 0.
So isn't cos 3 pi -1?
Yes, it is -1, so that will make this entire thing +5.
Okay.
The value of c is -5, so y will be equal to -5 cos 3x minus 2 sin x minus 6. Is this clear?
Yes, sir, it's clear.
Let's try to number 9. Come to this one now. Understand the question, bache. Question is telling us that P is this point and Q is this point, and Q also lies on the curve. So I cannot find the value or the coordinates of Q until and unless I have the equation of the curve. And I can get the equation of the curve once I integrate this entire thing, the dy by dx, right? So 3 sine of 3x minus pi by 2 divided by 3 plus c. Now, how do I find the value of c? I'll plug in the point that I already know. 3 pi over 3 minus pi over 2. So what is your value of c then? This will give me the equation of the curve. Where is c value? Now I can find the value of k. I just need to plug in k in place of y, which is the y coordinate, and pi over 2 in place of x. Now you can easily find the value of k.
So whenever